In my previous video, we saw how to set up a Kubernetes cluster on AWS using Terraform. So when I say infra, it is basically provisioning Kubernetes cluster and the database for digit. So in this video, we'll see what is the next step after the infra provisioning. So we need to prepare for deploying digit platform and the services. So as a first step, you will figure out, what it takes to connect to a Kubernetes cluster, how to get the kubeconfig, and then what are the config bootstrap. Like you have created a Kubernetes cluster, Kubernetes, database, and what are the credentials? How do we store it? Where do we store it? And how do we route the traffic through URL routes and global configs and service configs, and then Helm charts. So we deploy all our containerized services through Helm, and how do we override the values and stuff like that, and how do we prepare mdms configurations, which is nothing but master data, which is a JSON based configurations. And then we specifically have few other configurations like indexer, persister, and then state specific or like environment specific customizations like logos and JS files or stuff like that, right? And then we'll see how to deploy the backbone. So why do we call it as a backbone? So this really serves as a backbone to all our services. Like we have our Kafka cluster, which is again containerized, and Zookeeper supports Kafka to elect leader, and then we have elastic search stack, that is data, client, and master, and we have two elastic search stack, one for the product dashboards and another for our infra and log monitoring dashboard. And we'll see how to deploy cert-manager to manage the SSL certificates, and nginx-ingress to route the external traffic inside the cluster, and then zuul, basically, which is our API gateway. So it takes care of authorization. It has got various pre-filters, post-filters you can set for every service call. And then comes the core services. So core services has got like number of services that actually lays the digit underlying platform, right? So it has got various infra services and data services and stuff like that. And business and municipal services are the next level of services, like PGR, PTTL, fire NOC, stuff like that. And okay, so we also have a monolith applications like finance and eDCR, right? So how do we still containerize a monolith application, which is a fat jar, but still you'll be able to deploy on Kubernetes? And how do you seamlessly run inside a Kubernetes? And finally, the front end that serves, which is user facing, and what are the various routes that you need to configure, and how do you configure in nginx-ingress so that every route is recognized and it allows the traffic inside our services, to our services, right? Okay, so let's get started. So once you create a cluster using Terraform on AWS, so you need to run a specific config map that gets created by the Terraform. So that basically enables you to connect to your cluster, right? So how to download the kubeconfig? You need to run this AWS command. So there's a AWS CLI that you need to install on your local machine, and you have to have your AWS profile configured using AWS configure, and then you give the profile name, and then you give AWS access key, secret, region, and stuff like that. So with that, it sets the current AWS account credential so that when you execute these commands, so it automatically knows which account it has to connect to, right? So AWS EKS, and I'm saying the command update my kubeconfig, and hyphen name, the cluster name. This is basically the EKS cluster name, right? So this is my cluster name that I provided while creating a EKS cluster using Terraform. So after this, I'll just execute this command. It is going to give me the kubeconfig file. So since I already have it, I have saved it separately here with COVID UAT EKS, right? And you can manage your kubeconfig files, various kubeconfig files in a separate file, and then you can merge all of them into one using cluster merge command. So basically the command is which you can always keep it in your bash profile. So yeah, so this is the environment variable that you need to export to, and the values are cluster merge colon and all those various files you need to put here. So whatever the newly created kubeconfig, I'm just merging it here so that it'll, though all the kubeconfig files are in a separate files, so still it'll allow you to manage it in a single place. And also, like to make your life easy, executing various kubectl commands, right? You can always alias it. So in the internet, you can find the kubectl alias, like for example, you need a parse, you can just simplify it like this, and there are many things that you can alias it so that you don't need to type your commands. So now I have now I have my kubeconfig. So and I need to get the config map from the Terraform output. So Terraform output. So when you scroll all the way up, so this is what the config map that you basically need to run. So this will enable your EKS cluster to connect to your the worker node group, the auto scaling group that you have created, right? So how do you execute this? You save that file in a like this, and we'll say apply, yeah, kubectl apply. So it is going to create it, and make sure that you are in the specific cluster. Anyway, the path is different, but anyway, I have already executed this command, right? So now let me see if I'm able to connect to the cluster and able to query the Kubernetes objects. So I'm starting with kubectl get nodes, which I've aliased it. Yeah, here you can see, we have requested for 3 nodes, and the version that we have chosen is 1.15, and yeah. So successfully able to connect to the cluster, and what's next? So we are connected, we got the kubeconfig. Now we need to prepare the deployment config file, right? So why do we need a deployment config file? Because we are going to start deploying various services right now, right? So our Terraform is done. Now we need to get to the Helm, because we are going to deploy the various Helm charts, right? Okay, so inside InfraOps Helm, there is an environments directory wherein you maintain the various environment deployment config. So for example, the one that I recently created, COVID UAT. So you can either start from the scratch, or you can copy the existing one and just replace the values. So for example, so it has got some global values that your domain name is like common. I mean, it should be available across all. And then the cluster config, you would put under cluster config what are the various, you know, sections like root ingress, config maps, and again inside config maps you can have the global egov config. That means like these configs are available across all the services, and if anything specific to the service can be put here, right? So for example, egov file store, so this will have its specific S3 bucket I want to, which will change from an environment to environment. So I would like to always override based on the environment. So I can always pass my S3 bucket name here, right? So inside eGov config, the DB host, which you have recently created, you need to replace the DB host, and then your DB name, what's your DB URL, the JDBC URL basically, and then your FQDN and state level tenant ID, which is like a global override across. So it can be like if it is state specific, like for example, TN. So this can be TN and Punjab. So likewise, you can put your tenant ID, and there are several other configurations like your S3 bucket, basically for your assets like logos and JS files and stuff like that, and like you want to enable SMS. So these are some of the you know the configs that you would need every service to see when you deploy the pods. So each pod should have access to all these configs, right? And similarly, it has to know the URLs of the various services, right? So the this is how in Kubernetes every service is referred through the URL like this. So it's a namespace and then the service name and whichever the port it is running on, right? Okay, so now these are some of the things that like for this particular environment, like you need to decide which are the services that you are going to deploy, and what needs to be overridden. For example, I don't need a IDGen, or I need a IDGen, but you know format I don't want to pick. I do want to pick from MDMS, or I don't want to pick from MDMS. So all these overrides we should be able to do. This is SMS notification and user service, chatbot. Likewise, all these are various services, right? We have seen in the list, right? So Helm Chart, so I mean the various services like backbone, cert-manager, core services. So these are some of the core services, right? So now let's get started with deploying the backbone, right? So backbone is nothing but like we have Redis just for caching the tokens and the sessions and stuff like that, and Zookeeper, Kafka, Elasticsearch. So let's see how to deploy um, using the Helm as well as Python. So for backbone deployment, so we still use Python-based, deployment script. So it is not yet migrated to Helm, but both are seamless. Like, so what it does is like, yeah. So all you need to do is this execute this simple apply.python file. So it takes few parameters like, okay, so which is the environment that I need to consider and what is the module that I need to deploy, right? So this module is nothing but this service, right? So for example, like, I need to deploy this. So I can replace that with this. Right. And since this is a local, deployment, you need to ensure that you are already in that, specific context. Otherwise, it gets deployed in any other, you know, cluster. So you need to be sure that, when you execute anything locally, it should be in the right, connected to the right Kubernetes cluster, right? Okay, so now I want to deploy the first service Redis. So simply by mentioning, the module Redis. So what exactly it does, if you see, there is a definition that, okay, Redis and how many replicas? I want one replica. What is the image that I need to deploy? This one. So you can always change this, you know, to whatever the image, or else there is another way that, you can also mention here on the fly, this is the module, but instead of deploying 3.3, 3.4, right? So yeah, so before you execute this Python, you need to ensure that you export a specific environment variable that has got a secret. So only when the secret is set in your local machine, only then you would be able to use this Python script, right? So it is a kind of authentication, and that secret is basically an admin secret, right? Okay, so I need to deploy this one, and it is there in my script folder. Yeah. So before you deploy, you want to preview. So I mean, you're not sure that this is the first service that you're going to deploy, and how is it generating the manifest and how the manifest look like. So if you want to envision that, you can always, you know, do a dry run. So it will give you the manifest, like the final manifest, how it looks like. You can copy and okay. So as you can see, you know, it has created a deployment with the name Redis and the namespace, and there are selectors, and what is the container, you know, stuff like that, and what is the command that I need to execute. Okay, so it has created a deployment as well as the service, right? So now we are good to deploy this. So instead of a dry run, you can straight away deploy. Since I have already deployed this, the same version is already running, so it is not doing anything. Essentially, the Redis 3.2 it's already running, right? So if there is no change and you're deploying, it doesn't do anything. If at all there is a change in either the configuration or the image, only then it redeploys, right? So that's a Kubernetes feature. So likewise, we can start deploying, one by one. Like next is our Zookeeper, like we do. Okay, so before we do that, since this is a stateful set, we need to ensure that the volume IDs are placed correctly. For example, yeah, this is my definition of Zookeeper service. And here I'm saying, okay, it is a 3 replica, and the when you say this, okay, I need a persistent volume claim. These are my persistent volume IDs that you need to pick from EBS. EBS is AWS. If it is Azure, it will be Azure Disk. It will be, it varies from provider to provider, right? And these are like, since, um, you know, it, it's a multi-availability zone, um, cluster, and, you know, all these volumes are provisioned respectively on these availability zones, right? So you need to put the volume IDs, and you have to order it based on, like, for example, if the first one is in B, you need to ensure you order it like this so that it automatically understands, okay, where to look for this particular volume ID, right? So likewise, all the stateful sets should be mentioned with the volume IDs. And if you see, data, yes, master, right? So all these are. So where do you get these volume IDs from? Again, like, you can get it from your Terraform output, because while provisioning, it would have output all these volume IDs that it has created, right? So you need to put all of them here, and you will execute, Zookeeper environment as this, and then Zookeeper, and before you apply, you want to do a dry run to see. Right, as you can see, it has created a Zookeeper service for leader election, and then client, and then it has created and a stateful set, and the stateful set has got the volume IDs. Yeah, basically to mount the, is a mount path. Yeah, and these are some of the environment variables that we pass to override. Yes. So now, same way you can just apply it, it deploys. Similarly, you can follow the same for all the stateful sets. Like first you will deploy Zookeeper, then Kafka, Elasticsearch, and stuff like that. And also you will follow the same for cert-manager, nginx-ingress, and zuul. So you can find cert-manager. So cert-manager, and then ingress, stuff like that, and zuul, right? and zuul has got certain environment variables to be overridden, that has got the various whitelisting endpoints, stuff like that. Okay, so this is how you actually deploy using Python script from your local. And I mean, this is mostly the backbone setup is one time, and this is for the first time when you provision a infra for a specific environment, right? And let's look at, how do we deploy using Helm, right? So to deploy Helm using the local machine, you need to get into the folder inside infraops, egov deployer, and then you need to execute this command. So go run, there is a main.go, sorry, there is a deploy, and similarly, I mean, similar to the Python, there are certain parameters like what is the Helm directory and -cs config, I mean, cluster config true. We'll see what is that and which is the environment I need to, deploy it on COVID UAT, and which is the service that I need to deploy, right? So before I execute, let's see, how this is going to work. So when I say -c true, it is nothing but, the cluster config. So whatever the configs that change under this, if there is any change, and if you need to deploy that, you need to always set it to true. So in Jenkins, this is given in the form of checkbox. When you check that, it picks the latest configuration cluster config from the deployment and does it. I mean, deploys it. If you set it to false, it doesn't pick any of the latest changes from cluster config. It works with the existing, right? So before we look at the deploying Helm, so let's look at how the Helm charts are organized right now. So for example, we have a eGov file store, right? So eGov file store will have its Helm chart inside the respective category of services. Like for example, eGov file store is a core service. When you go inside core service, you can find eGov file store, and inside eGov file store, you will see values.yaml. So here you can see, there are some overrides. So values.yaml is the, standard way, how Helm offers you to override any of the defaults. So how do we know what are the defaults, right? So for example, these are the container default, like, the image, this is my image ID and how many replicas I want, app type, enable tracing, is fixed. So these are some of the values that are defaulted. And if at all you want to override from in based on your environment, right? For example, for COVID UAT, there are some of these values are going to specifically change. So you can always put those values in the here. So if there is any new value, you can always come here and add a new value here, right? And that gets, you can always go back to your values, and you can create that particular, um, you know, these are mostly the application dot properties, like, the the standard approach is like you would always caps it, and the hyphen would be replaced with the underscore. For example, new key, right? So this is the key that is there in your application properties for your service, and you can always, pick that value from, like this. So I want to pick this value from the value which is there in your COVID UAT as this, right? So that's how you do it. That's how you override it. Okay, so now then how does a final manifest look like after overriding all this, right? So this is what we have seen is just one level of override, and there is another level of override. So all these values should be uh, you know, substituted into your chart, right? So let's look at how our chart template look like. Okay, so my chart template look like I want a deployment for this service. I want an ingress for this service, and you need to create a service object in Kubernetes, right? So okay, so where is my template? Pick the template from common dot service. So where is it? So we have a common under Helm charts common. So here is the template. So what we are doing is we have templatized, the deployment manifest and then ingress manifest and service manifest, so that you don't need to have you know different templates for different services. So this unifies across all the services, and at the same time it gives you ability to override the way that I have just shown, like whatever the additional values that you need to put, you can always put here. And environment variables that beyond these, if you still want to read the environment variables from globals or from other secrets and stuff like that, you can always do that. Like these are the global secrets, and I want a AWS key to connect to a file store, right? So take it from the secret. Likewise, you can put all the overrides. And if there are certain overrides that will change from environment to environment, that is what you will put it here. So these values might change from an environment to environment, right? So this is how Helm charts are organized in our case. So yeah, this is how you will, using this command, you will actually deploy the Helm chart. And what if there are some secrets that you need to, keep it safe, and then you don't want to expose it, and still you want to use it runtime, right? So how do you basically create the secrets? So if you go to cluster config, and you can see there are various secrets. So for example, Giga file store secret, right? So there is a template, and it says that, okay, pick the value from cluster config secrets, and then eager file store. So where are the secrets coming from, right? So the secrets are coming from the file called, so whatever the environment name, you need to have a hyphen secret. So this you don't need to create manually. So there is a way you have to create. So we use SOPs, SOPs, that is secret operations, which is a tool, right? So which is basically used for encrypting your JSON or YAML files using a specific keys. It could be a PGP key, or KMS key, or like Azure, in Azure case, Azure Vault, and things like that. So let me show how it looks like. So this is the sops.sops.yaml. So we have got, like, for every environment, we have got a specific section saying, for example, in this case, like, for me, for COVID UAT, this is the file name, and these are the keys that you need to use for encrypting, right? So why there are multiple keys? So there are cases that, this environment can be used by your customers, partners, and then the other DevOps, folks, right? So you need to ensure, they should be seamlessly encrypt, decrypt using their respective keys, right? So, for example, like let's say the KMS, if this particular environment is hosted on AWS, and AWS is owned by a partner or a state customer, right? So they will have this particular key. So, and they will have a private key, and here this is the public key. Using the public key, we encrypt, and using the private key, somebody can decrypt, right? So it's not like we need all three, but any one would do. For encrypting, you need all three, or like you can even add more. So when you encrypt, you encrypt using all three, but decryption can happen if you have any one of these private keys. Like you have a PGP public key here, and like private key, if you have it in your local machine exported, you can decrypt this file. Likewise, if somebody has access to this, and they can decrypt. Likewise, we create the various secrets. Okay, so this is about encrypting, decrypting the secrets. So the advantage of this is like when you open this file, it's always encrypted. You can't see the real values, so that it preserves your sensitive data, right? And only the admins who has these keys, so only they will be able to decrypt these files using the command Helm secret. So when you execute this command, only then it opens the file in a decrypted mode. So you can directly change the values, and by the time you close, it automatically gets encrypted, right? So this is the advantage of it, though it gets into your Git repo, it is secured and things like that, right? Okay, so now let's go back to our Helm deploy command again. Yeah, so this is how you deploy from your local. And now, how will you actually create a Jenkins job for the teams to actually start deploying, right? So before you actually create a job in Jenkins, you need to ensure that you create a secret in Jenkins cluster. So basically, our Jenkins is running in a Kubernetes cluster. So you need to switch to Jenkins cluster, and you need to create this, kubectl create secret generic -n Jenkins, and this is the name that I want to create. This is the secret name that I want to create, and the content of this is picked from this file, right? So I need to pick the kubeconfig from this my local file. So it automatically picks content from here and creates the secret in your Jenkins. So once you do that, you'll go back to your Jenkins and you create a job like this, and your job actually has these things. So like this is like project-based security. You can restrict who can execute these using these are nothing but your GitHub teams, and here is what you're saying. Okay, so this is the environment name that you need to pick, right? So that's how it gets named as deploy to COVID UAT. So before you do your secret upload, so you need to ensure few things. So this is what you need to take care, like before you upload the secret, you ensure that you have your AWS access key and the secret key to connect to the EKS cluster. So that's how Jenkins can actually authenticate using AWS IAM Authenticator, right? So these are some of the dummy values. Um, so this is important. So before you actually generate the key, ensure that you follow this process. Okay, since I already have the secret key, I can create it, and secret generate is the Jenkins namespace. This is the name that I want. Create a secret from this file. can delete and recreate. Okay, so the kubeconfig got created. Now you come here and you can just save them with parameters, and you can pass which are the images, right? So we have seen the steps like deploying various services, right? So all the services can be deployed all at once in a bulk, right? Yeah. So these are some of the image IDs of various services. Like these are the municipal services and business services, and then these are backbone services. Sorry, these are core services, and these are some of the infra services and stuff like that, right? So all you can do is you can do all at once, or like you can go one by one, like the code, for example, like mdms and notification and stuff like that. You can it should be comma separated, and all you can do is copy everything and just put it here. And this is what the -c equal to true, right? So when you set this, so it picks the the latest cluster configs from here. Like if you have changed any value of this, so when you do that, it picks all those values, right? So let's not deploy everything. So you can do this, but I'm not just deploying the mdms source. So what it does now, it just picks this environment file and then goes to the eCar mdms service definition. So it says, okay, you're overriding the replica to 1, and this is the image ID, or now like this is the default one. When you mention this colon this one, it picks this as an image. It will override automatically, and it has got mdms path, and it has got a init container. So what is init container? So before a pod comes, if you want to run any the pre-steps, right? So that's the option that Kubernetes gives to run it as part of a container. So this is nothing but a pod comes up, and a git sync pod comes up. It clones this repo from this particular branch, and then once it clones, this is the path it will become inside the pod, right? So it will become a file. So inside a file, go to a working directory. So this is the folder inside that master config, and using that, start the service. So while it's deploying, I would like to suggest few useful tools. One is SOPs. So this is for encrypting, decrypting any YAML or JSON file, and another is k8s. So this is basically to manage your clusters, like let's say you have many clusters, you should be able to switch between the clusters, and then you can actually navigate to various things like pods and then deployments likewise, right? So as you can see, Jenkins is deploying the mdms service. Yeah, the deployment is successful. Let's see what is there. So what it does, it actually executes the same command, like inside you go deploy. So this is the Helm directory that I should pick, and cluster config true, and I believe COVID, the environment is COVID UAT, and this is the summary, right? So whatever we have done locally, this is doing it in the remote from Jenkins, right? So it has created a, since it is already deployed, it has not done anything, but it has created a service, it has created an ingress, it has created a deployment, right? So as we saw, these are the three manifests that it creates, the Helm templates create, right? So that is what is deployed. And as you can see, it is actually deploying. It is failing for some reason. So there are certain configurations missing. So this scaling, yes, helps you actually triaging and looking at the logs and switching between various, pods and stuff like that, right? And another tool I would like to suggest is the kubectx. So you can actually, read about SOPs, so how to install, so what it does and stuff like that. It has got very detailed information here. And k8s, how to install, what to do, what are the advantages. And then kubectx. Kubectx helps you, for example, like in a local machine, like you want to switch between the various contexts, right? So it will help you, listing down and switching and stuff like that. Yeah, so with this, we have done pretty much with all these topics.